The Maya is known as the name of a very small bird. But did you know that it's also the name of a very small satellite? Come and join me today as we learn more about this very small satellite, as well as about satellite tracking and orbits. I'm your host, Francesca Palabrica, and this is Sirkit Rikit. We are here today with Engineer Joven Javier, the project manager and technical lead for the Maya-1. Engineer Javier, thank you so much for being here with us today.
You're welcome. It's all my pleasure.
So, Engineer, could you tell us a little bit about yourself?
My name is Engineer Joven Javier. I am currently working in DOST Advanced Science and Technology Institute as a Senior Science Research Specialist.
Can you tell us about your position as the technical lead and project manager of Maya-1?
I usually supervise the team in the development from mission planning to the preliminary design up to the flight model stage, up to the satellite will be launching in space.
What issues did you have to keep in mind while making the satellite?
When we deal with the issues of making Maya-1, we have to deal with our teammates. So their schedules, because during that time, parallel with the development of that satellite, we are masters and we are PhD students. We have to do time management and you have to deal with the teamwork of every member. So you have to deal with their competencies, their assignment, the supervision, and we think about the mission of how this satellite will perform and do in space. You have to deal with the procurement and the design.
The Maya-1 satellite was 10 cm by 10 cm by 10 cm in dimension. So what would happen if it were any smaller or any bigger?
So if any smaller, it will be called picosatellites. So much less power, less mission, it can perform only few things in space, just like gathering sensor data, measuring the atmosphere maybe. On the other way around, the bigger the satellites, the bigger payload can put, like a camera, like a communication systems, and it will be much more complicated. Complicated means much more useful satellites. The bigger it is, the useful.
I've heard about the Diwata satellite. How does the Maya satellite differ from the Diwata satellite?
First, it's the size. So our Diwata satellite is a 50 kilogram satellite, while the nanosatellite, which is the Maya-1 or the CubeSat, is a 1 kilogram satellite. So in terms of weight and in terms of dimensions, they're really different from each other.
Are there any technical differences other than size?
Other than size, of course, the Diwata 2 satellite has a camera payload which can do better performance in terms of imaging the Earth, while the nanosatellite, because it's small, it has a limited power, so it has a limited mission like communication, technology demonstration, and experiment.
So we've been talking about satellites for a while. What are these satellites for?
Satellite is meant to be a spacecraft meant to be in space to perform specific missions like capturing image, communication, monitoring, and taking sensor data.
How do satellites move in space? Do they just float around randomly and do you just guess where they are? How do you know where a satellite is?
Okay, so the satellite is floating and tumbling in space when it is not doing anything. We usually track the satellite using a two-line element by means of the ground stations. Usually an antenna is used to communicate to our satellites by means of the radio frequency. So the radio frequency is an imaginary string attached from the ground station to the satellites. Our satellites has different orbit. We have geosynchronous orbit and low Earth orbit. So the geosynchronous orbit is the farther orbit. The satellite is put 35,000 kilometers above sea level. And the satellite at this position is moving same with the orbit of the Earth. So meaning it is 24/7 available to you. At this orbit, the satellite is usually used for communication, TV broadcast, and weather monitoring. The other way around is the low Earth orbit, which positions at 400 to 800 kilometers above sea level. So usually at this level, the satellite is moving so fast, so around 7 kilometers per second. And the satellite at this position, we usually do the mission like imaging the Earth. As I've said, the satellite is just floating and tumbling in space when there is no missions performed. But whenever the satellite reads something to do, like performing a mission, so it starts to stabilize, to focus the camera into the target and scan the area of interest. After that, to save power, the satellite goes tumbling mode again until it repeats the process. The satellite has two types of target missions when we are using the camera, especially for our Diwata satellites. One of which is the nadir pointing. Nadir is simply scanning the image of the Earth while the satellite is passing over the geographic area or area of interest. The image on the right is how the Diwata 2 performs the imaging in a locus area. On the upper left is the foresight. It means if you are inside the satellite, you can see how the satellite is moving, how it's flying fast, like 7 kilometers per second. The second mode is the target pointing, where the camera is focusing to the target while the spacecraft is moving through the horizon.
What do you see in the future for satellites?
So satellites is a space technology thing that in the future we can discover beyond what we are. So it can be used in a deep space to discover maybe a life, or just use the satellite to study everything on the ground.
What's the best part of the job?
The best part of the job is the appreciation, giving honor to the country, doing the first nanosatellite, the satisfaction of putting your fingerprint, your own design into the outer space, and inspiring the young generations of engineers and scientists.
Thank you so much, engineer, for taking the time out of your busy schedule to talk to us today about satellites.
Very much welcome.
And thank you for watching all the way to the end. Once again, I'm your host, Francesca Palabrica.
And I'm engineer Joven Javier.
And this is Sirkit, Rikit.